Good morning. Today we are going to look at functions, looking at them as rules or tables, rules and tables, and then tomorrow we will look at functions as graphs. So first, what is a function? Before we even get into these vocab words, I want you to think about a pop machine. If I push this button on the pop machine right there that says Coca-Cola, I should get out of the thing down here a Coca-Cola, right? So if you push that button, you should get out a Coke. If you push the button next to it that might say Sprite, you should get out a Sprite. So this is a function, it works. If I push this button that says Sprite and I get out a Coke, well, that's not supposed to happen. That would not be a function. Okay? So a function is for every input there is only one output. Just like whatever button you push, you should get one thing out. So our domain is really what we would put in to our function, our equation, our pop machine, whatever we're talking about. And those are going to be our x values. So notice values are going to be our numbers, our input numbers. Then our range is going to be whatever we get out. So if we're talking about an equation, whatever we plug in is going to be our domain. Whatever we get out is going to be those numbers, which we call our range or our y values. Then another way to say the same information, another way to say domain is just our x value, or our x, and then our dependent variable is our y. So a little bit of explanation here. Our domain has the word in right in it. That's what we're putting into our equation. Our range, that's what we're getting out. That's our y values. The g right here has a y right in it, so that's easy to remember. Range is y. Again, independent goes with domain, what we put in. Also, they match here, x's. Our dependent is what we get out, our y. So that one you just kind of have to remember. So let's take a look here. Same thing with, here's a red box. Whatever movies you select, you should get that same movie out. So it just says a relation is a set of ordered pairs that relates an input and an output. So you can list these in terms of ordered pairs x, y, or in an x, y table. You guys notice x is 2, y is 5. You put in an x, you get out a 5. It's the same information, okay? It's the same information. These are both functions because if you push the button that says 2, you get out something. If you push the button that says 4, you get out something. You get one thing out for each of these. It doesn't matter. It's a function. However, if I had another input that was also 2, I should get out a 5, but if I get out a 3 instead, that would tell me that this is not a function. It's not going to work because the input, if you push that one button that says Coca-Cola and you get out 1 Coke and 1 Sprite, it's not going to work. That would not be a function. So review, a relation is a function. For every input there is exactly one output. So let's take a look at a couple functions and explain whether or not it is a function. So remember, we need to look at our inputs. Are they all different? If I push this button, I get something out. I don't care what I get out over here for y, just something. So we plugged in a 4, we plugged in a 6, a 3, a 0, a -1, -7, and -2. All of those inputs are different, so yes, this is a function. And to explain why, there is one output for every input. You could say for every input there is one output. Same thing. Let's look at the next one here. We plugged in a 0, a 1, a 2, and a 3, like 4 separate buttons on the pop machine. And we got out 4 different things here. That's fine. Alright? This is also a function. For every input, there is one output. Alright, moving along, a couple more, same thing. Here are inputs. We have plugged in a 9, a 25, and a 25. Well, if I push this button that says 9 on the pop machine, can I get out a 3 and a -3? No, you can't. So this is not a function. And why? Because there's more than one output for the number 9 and for the number 25. Same thing here. It didn't work. Okay? It's like a broken pop machine. Looking at the next one, is this a function? We plugged in a 3, a 4, a -2, and a 3. Well, we have 3 there twice. If I push that button 3 on the pop machine, I shouldn't get out one thing here and something different over here. So this is also not a function, because there's more than one output for the number 3. Last one like this. Is this a function or not? If I push the button that says 0 on the pop machine, should I get out a Coke and a Sprite, a 2 and a 3? No. This one is also not a function, because there's more than one output for 3. Oh, not 3. 0. So some of you might be thinking, well, when is this okay? Can I have 2 Coke buttons on a vending machine? Yeah, that could be okay. You could have 2 different buttons as an input, a button 2 and a button 3, that both give you a Coke. That would be like this one here and this one here. That's okay. So on our next slide, they're asking us a different question, but if I just look at this information down here, here's a button that says 3 and a button that says 4. They're both giving me a Coke. We could have 2 buttons that give me a Coke. That's okay. So this is a function, but they're actually asking us a different question. So let's go back to the directions here. Identify the domain and the range of a function. Domain is what we're putting in, or our x's, our input. Our range is what we're getting out for y. So our domain, our input is going to be 0, 1, 2, and 4. That's what we plugged into something. And we got out our range, which is 5, 2, 2, and 1. If instead you just wanted to put 5, 2, and 1 instead of listing 2 twice, that's fine. And then same thing here, identifying first our domain. They give us a lot of information here. They explain again why this is okay, this is fine. But our input, we plugged in a 1, a 2, a 3, and a 4. And our range, what we got out was a 1, a 0, a 1, and a 2. So moving along, now we are going to make a table for our function using -2, -1, 0, 1, and 2 for our domain, what we're plugging in, and then identify the range, or our y's. So here is our rule, our equation that we are going to use. It says make a table, so I'm going to make an xy table. And they tell us we're going to plug in -2, -1, 0, 1, and 2. So we're plugging these in for x right there. So first we're going to plug in a -2, so -2 squared minus 1. This is where you need to be careful. This is really -2 times -2, which makes a positive 4. So 4 minus 1 is 3. Then we're going to do the same thing, plug in a -1. -1 squared minus 1. Again, -1 times -1 makes a positive 1. 1 minus 1 is 0. Then plugging in a 0. 0 squared is just 0, so 0 minus 1 is -1. Then plugging in a 1. Not -1. 1 squared is 1, and 1 minus 1 is 0. And then a 2. 2 squared is 4. 4 minus 1 is 3. So we made our table, and last it just says identify our range. So our range, our y values, we got out a 3, a 0, and a negative 1, because these are repeated. I don't need to list them twice. Let's try the same thing over here. Make an xy table. Plugging in negative 2, negative 1, 0, 1, and 2. First, it says negative 3 times x, and my first x over here is negative 2. And then we're going to add 2. So these multiplied give us 6, and 6 plus 2 is 8. Next, same thing. Negative 1 we're plugging in. Negative 3 times negative 1 makes a positive 3. 3 plus 2 is 5. Then plugging in a 0, anything times 0 is 0, so 0 plus 2 is just 2. And some of you might be seeing a pattern here. 8, 5, 2, what's happening? We're really going down by 3, so if I go down by 3 again, I should get a negative 1. Let's check. 8 to 3 times 1. Yep, negative 3 times 1 is negative 3. Negative 3 plus 2 is, in fact, negative 1. If I subtract 3 again, I should get negative 4. If you want to plug that one in, you do, in fact, get negative 4. So we also need to identify our range. Our range in this problem, we got out an 8, a 5, a 2, negative 1, and negative 4. But before we move on, I want to pause because in a minute we're going to be moving from this table to the equation. So before we start, let's make some assumptions here or some recognizations. We learned, or we noticed, that going down by 3 every time subtracting 3 was our pattern. That pattern actually is going to go with our x every single time. Whatever's in front of our x is always going to be our pattern. And then this plus 2. It's a positive 2 because whenever we have x is 0, y is a positive 2 for this table. If it was a minus 2 here, it would say minus 2. If it was a plus 5, it would say plus 5. So that is how these two relate. So let's look at our next problem, which says write a function rule. Another word for a function rule is just an equation that relates x and y. Identify the domain and the range. So first, we need to identify our pattern, making sure that our x's go by ones. 2, 3, 4, 5. So our pattern, what happens each time to get to one number from the next? From 3 to 4.5, we have to add 1.5. That also works moving along our y's. So in our equation is y equals 1.5x. Remember that pattern goes in front of the x. Then we need to figure out what's added or subtracted onto the end. We need to look for where x is a 0. Well, there is no 0 in our table, so we need to follow our pattern backwards the other way. To go back towards 1, instead of adding 1.5, we could subtract 1.5. 3 minus 1.5 is 1.5. If I go back to 0 one more time, subtract 1.5 again, I get 0. So this one happens to be a 0 there. 1.5x plus 0. Let's try the next one. Our x's go by ones, so let's look at our pattern. This one we're adding 3 each time. So in our equation, y equals 3x, and then look for a 0 in our table. There isn't one, so we're going to follow it backwards just one time this time. Instead of adding 3, subtract 3. 1 minus 3 is negative 2. So on the end there we have a minus 2. I'm going to pause right here. I want you to take a look at this one. It's tricky. Try this one and the next one, and then I'll go through the rest on your in the next video.